Good morning, student. Today we will study first chapter, measurement, in class 9th. The first topic is physical quantity. What is physical quantity? A physical property that can be measured and described by the number is called physical quantity. Suppose that how will you measure the weight of a person? Mass in kg. So mass is a physical quantity and kg is its unit. Similarly, length of anything like table, 3 meter means length is a physical quantity and meter is its unit. Area, so area is a physical quantity and meter square is its unit. Temperature is a physical quantity and Kelvin is its unit. Now, physical quantities are of two types. Number one, fundamental quantities. What are fundamental quantities? The quantities which do not depend on any other quantities, known as fundamental quantities, like length, mass, time, temperature. These are fundamental quantities. Now, second is derived quantities. What are derived quantities? The quantities which depends on other quantities, means more than one quantities. But the quantity which depend more than one quantity is known as derived quantities. Suppose that, for example, we take speed. Speed is equal to distance upon time or length upon time. So length is a physical quantity, time is another physical quantity. Now these are 7 fundamental quantities which you have to learn, and their unit and the symbol. Very important. 1 or 2 marks question used to come. Like mass is a physical quantity, unit is kilogram, symbol is kg. Length, physical quantity, unit is meter, symbol is m. Time, physical quantity, second is its units and s is its symbol. Electric current is the physical quantity, ampere is its unit and capital A is the symbol. Temperature, measured in Kelvin, symbol is capital K. Luminous intensity, candela, symbol is CD. Amount of substance, mole, symbol is mol. Now, these are some important derived quantities for your syllabus. Only these derived quantities you have to learn. Force is a quantity, unit is Newton, symbol is capital N. Pressure is a physical quantity, unit is Pascal, symbol is capital P, small a. Energy or work, like kinetic energy, potential energy, only energy, work, it is a physical quantity. Name of unit joule, symbol capital J, small j, sorry. Power, watt, capital W. Frequency, hertz, symbol is Hz. Electric current, coulomb, symbol is capital C, important. Electric resistance, ohm, symbol is this. Electromotive force or potential, volt. Now, next topic is the unit system. So there are some unit system are there in your syllabus. Number one is MKS system. What is MKS system? A system in which length is measured in meter, mass is measured in kilogram and time is measured in second, known as MKS system. It is a system introduced in France, or it is known as French system. Next is CGS system. It is also introduced by France and known as Gaussian system. These are important terms. Gaussian system. In CGS system, length is measured in centimeter, mass is measured in gram and time is measured in second. Now FPS system. This system was introduced in Britain and it is known as British system. In British system, FPS system, length is measured in foot, mass is in pound and time is in second. These are 3 important systems. Now, another system is known as System International. So, a new system has been introduced known as System International or International System. Short form is SI form. It is also introduced in French name, and the SI unit consists of 7 fundamental units which we have studied first. So that 7 fundamental quantities used to come in this SI system, and some other derived quantities are also come in this system. Another topic in your first chapter is vernier calipers. It is an instrument to measure the length. So these are the main parts of the vernier calipers. This is called inside jaws. This is outside jaws. This is vernier scale. It may be moved. And this is main scale. This is called tail. So these are the important parts of the vernier calipers. Inside jaws, outside jaws, vernier scale, main scale and tail. Learn this part. Now what are the work of these parts? First of all, tail. The tail is used to measure the depth of any beaker. Second is inside jaws. Inside jaws are used to measure the inner diameter, and outside jaws is used to measure the outer diameter. These are the function of these three parts. Now how to read the value in a vernier calipers? This is orange one is the vernier scale and this is main scale. So we have to see the zeroth division of the vernier scale. We can see that the zeroth division of the vernier scale is exactly matched to the fifth division of the main scale. 1, 2, 3, 4, 5. So one division on main scale is 1 mm. So 5 division on main scale, that is 5 mm. So what is the reading? That is 5 mm. Another example. Now in this, first of all we have to see what is the main scale value. We can see this is the 20th division. So it is 21, 22, 23. So 23rd division of the main scale crosses the 0th division. So the main scale reading is 23. Main scale reading is 23. Now vernier scale reading. We have to see which division of the vernier scale match exactly to any division of the main scale. So we can see that the 4th division of the vernier scale exactly match to this line. So the reading of vernier scale is 4 into 0.1. So that is equal to 0.4 mm. So 0.4 mm plus 23. So it will be equal to 23.40 mm. Now this is your homework. You have to read this value and let's take how to read. This is the value 3 centimeter or 30 mm. So it is 3 centimeter, 3.1, 3.2, 3.3, 3.4 and 3.5, 3.6. So the main scale reading is 3.6. So of course this may be the answer. Now read the vernier scale reading. So which division of the vernier scale exactly match? See, 5th, 6th, 7th, 7th division. Because we are measuring in centimeter, so 7th division means 7 into 0.01 centimeter. So it will become 0.07. So 0.07 plus 3.6. So the answer will be 3.67 centimeter. Now another topic is least count of the vernier calipers. So what is the formula? So least count of the vernier caliper is equal to value of one division on main scale divided by total number of division on vernier scale. So one division in main scale is equal to 1 mm or 0.1 centimeter. If there are 10 division in vernier scale, so 1 divided by 10, that is equal to 0.1 mm, or 1 divided by 10, sorry, 0.1 divided by 10, that is equal to 0.01 centimeter. Now this is your homework. You have to write the name of these parts which we have initially discussed. Another instrument in your syllabus in first chapter is screw gauge. These are the main parts of the screw gauge. This is called anvil or stud. This is spindle. This is main scale, or you can say sleeve. This is the circular scale or rotating scale. This is thimble, and this is ratchet. Now, how to read the reading in screw gauge? In the diagram, it is clear that the main scale 1, 2, 3, 4, 5, 6, 7. 7 divisions in main scale are clearly visible. So the main scale reading is 0.7 centimeter. Now we have to see which division of the circular scale match to this baseline. This is 35, 36, 37 and 38. So 38 division is matching to the baseline. So 38 into 0.001. So 38 into 0.001, that is equal to 0.038 centimeter. On adding these two values, 0.7 plus 0.038 will equal to 0.738 centimeter. This value is in mm. This is in centimeter. Now, this is your homework. In this diagram, you have to calculate the value. Suppose that first I am going to discuss. This is one division. This between the two divisions, it is a small line. It is 0.05 mm. So this is 1 mm. This is 2 mm. So it is 2.5 mm. So the main scale reading is 2.5 mm. Now the vernier scale reading, it is 45, 46. So 0.25 centimeter plus 46 into 0.001. So that is equal to 0.046. So 0.25 plus 0.046. When you will add, you will get the final result. Similarly, you have to calculate for this diagram. You have to calculate these two as well as these three. This is your homework. Now, the error. We have two types of error. Positive zero error and negative zero error. What is positive zero error? It happens when the zero of the circular scale. This is the circular scale and this is the zero of the circular scale. When the zero of the circular scale placed below the zero of the main scale. So this is the zero of the main scale. If the circular scale 0 lies below to the main scale 0, it is called positive zero error. This is negative zero error. What is negative zero error? It happens when the zero of the circular scale placed above the zero of the main scale. See, this is the baseline and this is 0 of the circular scale. So when the 0 of the circular scale lies above the 0 of the main scale, it is known as negative zero error. Now, we see the 0 of circular scale exactly matched to the 0 of the main scale. It is no zero error. And this 0 of the circular scale lies below the 0 of the main scale, so it is positive zero error. And this 0 of the circular scale lies above the 0 of the main scale, so it is negative zero error. What is least count of a screw gauge? So least count of screw gauge is the pitch of the micrometer. Pitch means value of one division on main scale upon total number of division in circular scale. So the value of one division in main scale is 1 mm and circular division are 100. So the least count will be 1 upon 100, that is equal to 0.01 mm or 0.001 centimeter. Another topic for this chapter is simple pendulum. So what is a simple pendulum? A simple pendulum consists of a metal bob which is suspended freely from a fixed point using an inelastic string. Let's see the diagram. This is the bob, this is the string, this is fixed point. These are the maximum displacement point. So the maximum displacement from the mean position is called amplitude. This is another example, another important definition for this topic. What is amplitude? The maximum displacement from the mean position is known as amplitude. Next is period or time period. The time taken to complete one oscillation is called time period. Or you may say, suppose that for 10 oscillation, the time is 10 seconds, then the time period will be equal to 10 by 10, that is equal to 1 second. Now frequency. What is frequency? The frequency is the number of oscillation taken in 1 second. So F is equal to number of oscillation divided by time, that is equal to frequency. This is the formula of time period. Time period is equal to 2 pi under root L by G. See in this diagram, see in this formula, the time period does not depend on the mass of the ball. So the time period of a simple pendulum is independent from the mass. Now, a very important topic is there in your syllabus, that is the graph of L versus T square. L is called length of the pendulum and T is the time period. So only this diagram you have to draw. Don't write these values. This is y-axis, this is x-axis. On x-axis you have to mark L in meter. On y-axis you have to mark T square in second. And draw a line from these two axes. This is the graph of L versus T square.